All right. So, uh, let's explore some scenarios where we're provided with some premises, one of which is a conditional statement, and the other of which is just some additional information, right? So this is where we start to do some reasoning with conditional statements. It's where we really put it all together. I'm going to start with, well, I'm going to hold off to that, on that. We're just going to start with a scenario, okay? A scenario, and you need to examine this scenario, okay? Here it is. There are two premises. If a person challenges a creditor's report, then the credit bureau will conduct an investigation for that person. The second premise, Ronald Whitney challenged a creditor's report. So I'll leave you to stare at that for a moment. And what conclusion can you draw? So hopefully you've had a chance to stare at this and think about it. What you should notice is that the first premise, premise number one, was a conditional statement. If P, then Q. We all see that? If a person challenges a creditor's report, a person challenges a creditor's report, that's the P. Agreed? So then we look at the second premise. Ronald Whitney challenged a creditor's report. Notice how that statement aligns with the hypothesis, the P in our conditional statement. If a person challenges a creditor's report, Ronald Whitney challenged a creditor's report. So the first statement, the first premise was an if P, then Q statement. And the second one was basically saying P happened, right? That means that the hypothesis P was true. And there's something called the law of detachment. I think this is a fun one. The law of detachment. The law of detachment states that when a conditional statement is given and the if part is satisfied, right? The if part is the P. We say it's satisfied if another premise says so, then the then part will logically follow, right? So again, we have an if part, and that if part came true based on the second premise. Well, if that's true, then we know that the Q part will logically follow. So what conclusion did you draw? That the credit bureau will conduct an investigation for Ronald Whitney, probably, right? That's what it says. You can also show these using Venn diagrams. Again, hopefully one of the things that you are learning is that images are powerful, right? Images allow us to see all sorts of things. And it's one of those things we want students to be able to do as well, right? We can see that the outer circle is people for whom the credit bureau conducts an investigation. Inside the red is people who challenge a creditor's report, and there's Ronald, right? Ronald did, so that means there will be an investigation. All right, so here's another one, a very similar situation. So here are two statements. So again, I will let you read these on your own paused video and see if you can make sense and figure out what conclusion you can draw. An extra word there. All right. Hopefully you've had a chance to read these and come to some logical conclusion. I like this one. So this says if the temperature drops below 65 degrees Fahrenheit, then the heater will activate. Again, what you'll see here is a conditional statement. If P, then Q. The P is the temperature drops below 65 degrees Fahrenheit. Here's the P. The Q is the heater will activate. Okay. Well, then there's a second premise that says the heater did not activate on Wednesday. Okay. So the heater did not activate. Which statement is that associated with? The hypothesis or the conclusion? The P or the Q? The heater did not activate. That's associated with the conclusion, the Q. But you also notice it is the not version. It's the negated version. So what we have here is a premise. If I simplify all this, we've got two premises. And the first one says, if P, then Q. The second one is really saying, not Q. Agreed? If P, then Q. So what happened? Not Q. Does that look familiar? Doesn't that sort of take you back to the contrapositive? So the contrapositive, if I scroll back, to where we were, contrapositive said, if not Q, then not P. That's the statement that we're going to use. That's the reasoning that we're going to use here. So there is a second law. We use the law of detachment. And now we're going to use what is called the law of contraposition. The law of contraposition states that when a conditional statement is given, which we had, and the negation of the then part is satisfied, not Q, the if part will logically follow. So again, if P, then Q, not P, not Q is what happened. So we can conclude not P, right? Not P. Let's look at a Venn diagram. See if that helps us make sense of this. Here is a diagram. Days when the heat is activated, the heater is activated. Days when the temperature drops below 65 degrees. Here's Wednesday. Heater was not activated. So what can we conclude? Well, it did not drop below 65 degrees, right? This is not able to be inside this circle. Wednesday could not possibly occur inside this circle. So what's our conclusion? Our conclusion is on Wednesday, the temperature did not drop below 65 degrees. Okay. And that's that law of contraposition. Again, when a conditional when a conditional statement is given, then the and I've got to actually add a word in here, then the negation, I should say, the negation of the if part will logically follow. I believe I said that earlier, but I didn't have that typed in. Again, the law of contraposition states that when a conditional statement is given, again, if P then Q, and the negation of the Q is satisfied, then the negation of the P is what we can logically deduce. This is deductive reasoning. All right. So what I'm going to do, just to test you here, is I'm going to give you a situation and a conclusion, and your job is to determine which of those two laws, detachment or contraposition, which law was used in this scenario. The first one is if a trip is over 300 miles, campers will run out of gas. Campers did not run out of gas. The conclusion then is the trip was not over 300 miles, and that is a valid conclusion. So can you figure out which of the two laws was used here? I'll give you a minute to pause and think about that. So let's analyze. How do we think about this? Here is our if-then statement. If P, then Q. A trip is over 300 miles, that's the P. Campers will run out of gas, Q. Campers did not run out of gas. So this is the negation of the Q. So we can say if not Q, then not P. Not P would be a trip is not over 300 miles. And that was the conclusion that was stated. So which law was used? The law of contraposition. The law of contraposition was used. So here's the second one that I'd like you to take a look at. Second example. And it is, if Jan applies for a job, she will be hired. Jan applied for the job. Jan will be hired. It's a valid conclusion. Go ahead and pause. Think about this. Again, what we have here is an if-then statement. If P, then Q. P is Jan applies for the job. Q is she will be hired. Jan applied for the job. That is associated with the P. So the hypothesis was satisfied, which means Jan will be hired is our logical conclusion. There's no negation of anything happening there. It says if P, then Q. P happened, so we can conclude Q. That's the law of detachment. The law of detachment. So the last thing we will do here is kind of what I think is maybe it's the highest level thinking, and maybe the most important thing that we end up being able to do. And this is determining validity, determining whether a conclusion is valid or not. So this is next level thinking. So I'm going to give you some statements, some premises, some conclusions, and your job is to determine whether or not this is a valid conclusion given the information that you were given. All right. So for each of these, again, pause the video, read it, pause it, and try to determine, is it valid or not? And can you determine why? Okay, I'll give you a chance to pause and then come back here. So again, that should say conclusion right there. Oh, I did have that. So the premises were, if a company fails to have an annual inspection, then its license will be terminated. There's our conditional statement. The Samson Company's license was terminated. All right. So here's our P and here's our Q. All right. So P, Q. If a company fails to have an annual inspection, then its license will be terminated. The next premise says the Samson's company's license was terminated. So that's associated with the Q, right? That's associated with the conclusion. So can we then make draw the conclusion that the Samson company failed to have an annual inspection? So this is really saying, if P, then Q. The second premise was Q happened. And the conclusion that's drawn is, well, if Q happened, then P happened. Is that something we can conclude? If you think back to all three of those original associated related statements, that is an example of a converse. Remember, the converse was if Q, then P. Was a converse statement always true? No, it is not always true. Just because Samsung Company failed, or just because their license was terminated, does not mean that they failed to have an annual inspection. They could have, but they might have had their license terminated for many other reasons. If we look at a Venn diagram, right, because we know Venn diagrams are very helpful, Venn diagram could look something like this. There are companies whose license will be terminated. Inside there are the companies that failed to have an annual inspection, right? We know if they failed to have an annual inspection, then their license were terminated. But there are other reasons that they may have had their license terminated. All we know is that Samsung had their license terminated. It doesn't mean that we can guarantee that they belong inside this red circle. So this is an invalid conclusion. This conclusion is invalid. We cannot say that this is true or not. It may or may not be, but we did not use proper deductive reasoning. Okay, let's look at another one. This is my favorite. All right. Premise. Go ahead and pause this, read this, and see if you can determine if this is true, if this is valid or not. All right. So the first premise is, if the Detroit Lions have won the Super Bowl, then pigs will have learned to fly. All right. If the Detroit Lions have won the Super Bowl, there's our P. Pigs will have learned to fly. There's our Q. No pigs have learned to fly. This is associated with Q, and it's also the negation of it. No pigs have learned to fly. The conclusion drawn is the Detroit Lions have not won the Super Bowl. Is that valid or not? And why? Well, what do we have? Here's what I read. If P, then Q. That's our first premise. The second premise is not Q. And the conclusion is, after reading those, the conclusion is not P. The Detroit Lions have not won the Super Bowl. Does that line of reasoning hold? Is that valid? It absolutely is. Why? Because of the law of contraposition. This is a valid conclusion. Remember, if P, then Q. If not P, then not Q. That's the contrapositive, and that is logically equivalent to the original statement. So, contraposition. The law of contraposition is what was used here. And finally, your last one. Again, pause the video once I get this up, read it, try to make sense of it, and try to determine if this is a logical conclusion. So this says, Premise one, if a person is a Florida resident, he or she will qualify for the tax deduction. Mallory is not a Florida resident. The conclusion is Mallory will not qualify for the tax deduction. So let's see. Premise number one, if P, then Q. The P is a person is a Florida resident. The Q is he or she will qualify for the tax deduction. So the second premise has to do with the P. A person is a Florida resident. Mallory is not a Florida resident. However, it's the negation of that. The conclusion is Mallory will not qualify for the tax deduction. Not. So what line of reasoning was used here? If P, then Q. The second point was not P. And the conclusion then was not Q. Is that a logical line of reasoning? Think back to the original, again, the three different relationships with conditional statements. Again, we had converse, inverse, and contrapositive. The inverse, remember the inverse? The inverse said, if not P, then not Q. And was that always true? No, it was not. Just because Mallory is not a Florida resident does not mean that Mallory will not qualify for the tax deduction. This is invalid. She may not qualify for the tax deduction, but all the original statement the original conditional statement said was, if a person is a Florida resident, then he or she will qualify for the tax deduction. It didn't say anything about people who are not Florida residents. So I think this is some of the most challenging type of thinking and reasoning that you're going to be doing in this chapter, in this class. It's definitely challenging. This is something that not everybody is great at. But it's important to know deductive reasoning is so crucial, right? It allows valid conclusions based on premises without completely understanding the subject. You've got your Venn diagrams that you can use to help show and clarify how things relate. And those are especially good for young learners to draw those pictures. It helps ensure that you're avoiding invalid reasoning and just keep those different logical rules in mind, right? Inverse, converse, contrapositive, detachment, and which lead to true statements and which lead to statements that are not always going to be necessarily true.